Welcome to the Explainer. So we're going to get right into it and unravel the story of how we taught machines to talk, to write, and, even to reason. This is the story of large language models, how we went from these pretty basic word predictors to the kind of AI that is literally reshaping our world as we speak.
You know, this one single question has been the driving force behind decades of AI research. It's a huge one. How do you take this beautiful, messy, super nuanced thing we call human language and actually teach a machine to get it, to truly understand it?
Okay, Section 1, the quest for machine language. Every revolution has to start somewhere, right? For LLMs, it all began with laying down the essential groundwork. The core concepts that everything else is built on top of.
All right, first things first, let's just get our terms straight. It's kind of like a set of Russian nesting dolls. You've got artificial intelligence, AI, as the biggest doll. That's the whole grand idea of creating intelligent machines. Inside that, you have machine learning, or ML. That's a huge piece of the puzzle. It's how we teach them, mostly by feeding them just massive amounts of data. And then inside that, you've got deep learning, which uses these really complex structures called neural networks to find all the subtle patterns in that data. So when you take all that power, AI, ML, deep learning, and you point it squarely at language, that's when you get what we call natural language processing, or NLP. And really, this is the specific quest we're on, closing that massive gap between how we humans talk and how computers, compute.
So now we get to the early models and the big hurdles they faced. The first attempts at NLP were, pretty clever for their time, but they all, and I mean all of them, smashed right into the same massive wall, a single bottleneck that basically stopped progress in its tracks for years. Yeah, the evolution here really happened in stages. At first, you had these pretty simple statistical models. Their whole job was just to guess the next word based on the last couple of words. Kind of basic. Then things got a little smarter, with early neural nets that could figure out a word's meaning from its neighbors. But the real leap forward came with what are called sequential models, like RNNs. The idea was great. They were designed to read a sentence word by word, just like we do, trying to keep a sort of running memory of what was just said.
But that was the bottleneck. I mean, think about it. Imagine you're reading a long paragraph, and by the time you get to the last sentence, you've completely forgotten the first one. That's exactly what was happening to these models. They basically had the memory of a goldfish. They'd lose all that crucial context and meaning as soon as the sentence got a little too long.
So, let's move on to the Transformer revolution. And then, 2017 happened. A single research paper dropped with this amazing title, Attention is All You Need. It introduced a new architecture that didn't just move the goalposts, it completely changed the entire game. This was, no exaggeration, the eureka moment for AI language.
So what was the secret sauce? It was this thing called the attention mechanism. Now get this, instead of reading a sentence one word at a time sequentially, this new method allowed the model to see the entire sentence all at once. It could instantly look at every word and figure out how important it was to every other word, no matter how far apart they were. This completely solved the memory problem, but maybe even more importantly, it allowed for what's called parallel processing, chewing on the whole sentence simultaneously. And that meant we could suddenly build and train these models on a scale that was completely unimaginable before. And this one breakthrough, this attention idea, immediately created two different paths forward, two powerful new types of models. On one side, you got models like BERT. BERT reads text from both directions, forwards and backwards, to get a really deep understanding of context. It's why when you type something into Google search, like who played the lead in the movie Castaway, it knows you're talking about the actor, Tom Hanks, not a literal castaway. Then on the other side, you got models like GPT. These are absolute masters of predicting the next word in a sequence, which makes them incredible at generating brand new, creative text. Basically, at talking.
All right, Section 4, how LLMs are built. So with this new transformer architecture as the engine, the race was officially on, and the new philosophy was simple. Go big. No, I mean really, really big.
And this number, 175 billion, it perfectly captures that new philosophy of massive scale. We're talking about parameters here. You can think of each parameter as a tiny little knob that the AI can twist and tune to get better and better at understanding language. To put that in perspective, early models had thousands of these knobs, maybe millions if they were cutting edge. The new generation? Billions. It's this immense scale, combined with training on basically a huge chunk of the entire internet, that gives them their incredible power.
So, how do you actually build one of these giants? Well, it's basically a two-step process.
The first part is called pre-training. Think of this like sending the AI to university. It just absorbs everything it can about language, grammar, facts, different styles of writing, even a bit of reasoning from a gigantic data set. It becomes a generalist. Then comes fine-tuning. This is like giving the AI its first job. You take that super smart general-purpose brain and you specialize it for a specific task, like maybe translating languages or writing computer code.
Okay, next up, using these things in practice. So these incredibly powerful models are out there, but how do we, actually talk to them and get them to do useful stuff for us? Well, that brings us to what is basically a brand new skill for all of us, prompt engineering. It turns out the quality of the answer you get from one of these models depends almost entirely on the quality of the question you ask it. Learning how to craft these clear, context-rich instructions, these prompts, is the absolute key to unlocking what they can really do. And just like that, this technology is, it's everywhere. It's powering the chatbots you talk to for customer service. It's the magic behind the tools that help programmers write complex code in seconds, just by describing it in plain English. It's inside the apps that can take a 20-page report and spit out a perfect summary. This stuff has officially left the research lab and landed right in the middle of our daily lives. So let's talk about the future and its challenges, because of course with all this incredible new power comes a whole new set of very, very serious challenges that we now have to figure out. Yeah, one of the biggest problems we have to deal with is something called hallucination. It's a weird term, but what it means is that because these models are designed to generate text that sounds plausible, they can sometimes just make stuff up, and they'll say it with absolute confidence, even if it's completely wrong. It's so important to remember, they are expert pattern matchers, not fact checkers. And that leads to this really fundamental tension, a huge debate happening right now in the AI community. On one side, you have the push for open models, where all the code and data is made public. The idea is that this promotes transparency and lets everyone innovate. But on the other side, you have closed models, where the technology is kept proprietary. The argument there is that it gives the company who built it more control to make sure it's safe and isn't misused. It really boils down to this core debate, access versus control. And that really brings us to what might be the most important question of all. Think about it. These models are trained on us, on our words, our ideas, our history, our internet. They are, in a very real sense, a reflection of humanity, all the brilliant parts and all the ugly parts too. So, as this technology gets woven deeper and deeper into the fabric of our lives, the critical challenge for all of us is, how do we make sure that the reflection they show us is one we're actually proud of?